Hello everyone, my name is Sandy Winarko. I'm a Principal PM for Azure Data Governance at Microsoft. My team develop and manage data integration products, including Azure Data Factory or ADF and SQL Server Integration Services or SSIS.
In today's Paas virtual summit session, I will cover everything you need to know to accelerate the migration of legacy SQL Server Integration Services or SSIS with Azure Data Factory or ADF. Here is a reminder of everything Paas has to offer. And here is a reminder to submit your session evaluation. Let's preview the learning objectives or takeaways from this session. First, you will learn how to rehost your existing extract, transform, and load or ETL workloads in the cloud, including all SSIS packages and jobs, with minimal or no changes using the fully compatible SSIS in ADF. You will learn to prepare an all-path solution of Azure SQL Database or Managed Instance and SSIS in ADF, essentially decoupling your database and ETL engines. Once your all-path solution is prepared, you will learn the three-step iterative process of package assessment for cloud compatibility, package execution testing in Azure, and package redeployment or migration to Azure. And once your packages are migrated, you will learn to operationalize your ETL workloads in the cloud with continuous integration and continuous deployment or CI/CD across your development, testing, and production environment using ADF, Azure Monitor, and Azure DevOps. Next, you will learn to enhance your ETL workflows using first-class SSIS activities in ADF pipelines that can be combined with other complementary ADF activities, opening the door for big data or modern data warehouse patterns. And finally, you will learn to extend your ETL workflows using custom open source or third-party components for SSIS in ADF that allow you to fill functionality gaps and innovate in data integration. So remember the mantra to be repeated throughout this session: rehost, enhance, and extend. Let me provide a flash introduction that first separates SSIS from ADF and then joins them together as SSIS in ADF based on the different customer cohorts and scenarios they are targeting. SSIS, which should be familiar to most of you, is a traditional ETL tool that comes bundled with SQL Server. It's used to extract, transform, and load data with SQL Server as data source or destination. It's mainly targeting customers who want to manage their own infrastructure on premises. To use an analogy, running traditional ETL workloads on premises as SSIS packages and jobs is like being on the ground floor. ADF, which might still be unfamiliar to some of you, is a cloud-native ELT platform as a service or PaaS. It's used to extract data from various sources, load it into a data lake, transform it using big data compute such as Databricks, Apache Spark, or Azure HD Insight, hence the term ELT, and finally ingest it into a data warehouse such as Azure Synapse Analytics, where it can be visualized using a business intelligence app such as Power BI. It's mainly targeting customers who follow the just described modern data warehouse or MDW patterns. To use our analogy, running modern ELT workloads in the cloud as ADF pipelines, activities, and triggers is like being on the 7th floor. Since SSIS has been around for much longer than ADF, many customers have accumulated investments in legacy SSIS packages and familiar tools for their SSIS operations. To continue our analogy, converting hundreds to thousands of their existing SSIS packages and jobs into ADF pipelines, activities, and triggers all at once, while retraining their teams to operate new tools at the same time, is like jumping 7 stories straight up, which is virtually impossible. Enter SSIS in ADF, which is an ETL PaaS integrated with ADF. It is used to run existing SSIS packages with minimal or no changes in ADF. It is mainly targeting customers who migrate their SQL Server to the cloud. Once your packages are running in ADF, you can leave them alone or gradually enhance or replace them at your own pace with ADF pipelines and activities. Some customers still run all of their original SSIS packages in ADF, while others have already enhanced or replaced some packages with ADF pipelines and activities. To conclude our analogy, Running SSIS in ADF is like taking an escalator that seamlessly carries you to the 7th floor step by step with the option to get on or off anytime at any floor. As SSIS continues to be bundled with every new version of SQL Server, more and more packages will be created to run on premises. And when it's time to migrate SQL Server to the cloud, SSIS in ADF is the path of least resistance for those packages. So the rumors of SSIS deprecation were greatly exaggerated and cannot be further from the truth as we continue to invest in SSIS both on premises and in the cloud. Let's break down SQL migration using an all platform as a service or PaaS solution. We start with a typical SQL Server estate on premises, including its bundled value-added services or VAS, such as SQL Server Integration Services or SSIS, SQL Server Analysis Services or SSAS, and SQL Server Reporting Services or SSRS. When you migrate your SQL Server to the cloud, we recommend an all PaaS solution of Azure SQL Managed Instance or SQL MI and SSIS in ADF to separately host your database and ETL engines respectively. SQL MI is a variant of Azure SQL Database or SQL DB that offers almost 100% backward compatibility to SQL Server. Likewise, SSIS in ADF is fully compatible to SSIS on premises, such that you can rehost or lift and shift all of your existing packages with minimal or no changes. For SSAS, you can rehost your tabular data model on Azure Analysis Services or AAS, which is also a PaaS solution. If you have a multi-dimensional data model, AAS does not support it yet, so you can leave SSAS on premises or rehost it on Azure VM, which is an infrastructure as a service or IaaS. For SSRS, there is no PaaS solution for it yet, but you can upload its existing reports and completely replace it with Power BI, which is a software as a service or SaaS. Now that you perform data integration using SSIS in ADF, it can connect to various resources on premises and in the cloud. For example, it can fetch packages stored in MSDB or SSIS DB hosted by SQL MI. It can still access databases hosted by SQL Server on premises. It comes with built-in components from SQL Server Standard and Enterprise Edition, such as SAP, Oracle, and Teradata connectors, Change Data Capture or CDC components, Analysis Services or AS component to access AAS and SSAS, and Power Query source to run Power Query scripts generated from Excel or Power BI. It also comes with pre-installed components from Azure Feature Pack, such as Flexible File Source, Destination, and Task to access Azure Blob Storage, Data Lake Store, etc. Using SSIS in ADF, package execution can be invoked as first-class SSIS activities in ADF pipelines, so they can benefit from cloud-first, cloud-only features and be chained or combined with other complementary ADF activities, thus enhancing your ETL workflows. For example, connectivity gaps in built-in or pre-installed SSIS components can be filled by ADF that has more built-in connectors, and vice versa. Functionality gaps in native ADF activities can be filled by SSIS that also offer virtually unlimited extensibility. SSIS in ADF offers a custom setup interface to extend your ETL workflows. Many of our ISV partners have adapted their commercial SSIS components to run on SSIS in ADF via standard custom setup scripts. Some of them have even deeply integrated their components on SSIS in ADF via express custom setups without script. For example, one of our partner, OH22 Information Services, have built a cloud alternative to DQS, or Data Quality Services, that's also bundled as a SQL Server VAS. Their product can be purchased in Azure Marketplace, supports DQS migration, and runs completely in Azure, orchestrated by SSIS in ADF. Let's trace the evolution of SQL Server Integration Services, or SSIS, from on-premises to the cloud, highlighting new enablers and features that unblock and accelerate SSIS migration. As most of you know already, SSIS is a traditional extract, transform, and load, or ETL tool that has been around for a long time. It's born as Data Transformation Services, or DTS, in the year 2000, revamped as SSIS in 2005, and always supports the package deployment model, where you deploy your SSIS packages into file system or SQL Server database, or MSDB. In 2012, we released the project deployment model, where you deploy your project or packages into SSIS catalog or SSIS DB hosted by SQL Server. Throughout its history, customers continue to use familiar tools such as SQL Server Data Tools, or SSDT, SQL Server Management Studio, or SSMS, as well as dtutil and dtexec command prompt utilities to design, deploy, configure, and execute their packages. There is also an established ecosystem of third-party components from our independent software vendor or ISV partners that extends its functionalities. In terms of pricing, it's always been bundled with SQL Server as free value-added services, or VAS. In 2017, we released Linux support and scale-out feature that allows you to run many SSIS packages in parallel using a single master multiple workers topology. This architecture also forms the foundation for SSIS Platform as a Service, or Paas, in Azure Data Factory, or ADF, that's released in the summer of 2018. When we released SSIS in ADF, we separated storage resources where you deploy and store your packages from compute resources where you run them. So you can scale these resources up and down or in and out independently. For storage resources, we support both project and package deployment models, where you can store your packages in SSIS DB hosted by Azure SQL Database or Managed Instance, or SQL MI, in MSDB hosted by SQL MI, in Azure Files, or in File System. For compute resources, we use ADF to provision a managed cluster of Azure Virtual Machines, or VM, dedicated to run your packages. We call this Azure-SSIS Integration Runtime, or SSIS-IR. For design, management, and orchestration tools, we have preserved your skill sets by ensuring that familiar on-premises tool can still be used in the cloud. For example, we have Azure-enabled SSDT, SSMS, as well as dtutil and dtexec command prompt utilities. We have also turned Azure-enabled SSDT into an all-in-one SSIS migration tool, where you can perform the three-step iterative process of package assessment for cloud compatibility, package execution testing in Azure, and package redeployment to Azure. On ADF user interface, or UI, you can configure your package execution as first-class SSIS activities in ADF pipelines. If you use SQL Server Agent to orchestrate your package execution on SQL Server, you can now use SQL MI Agent to orchestrate them on SSIS-IR in ADF. On SSMS, you can now use SSIS scheduling features to auto-create SSIS activities in ADF pipelines, or SSIS Job Migration Wizard to convert SSIS jobs in SQL Server Agent into SSIS activities in ADF pipelines. If you use third-party tools such as Control-M or Active Batch to orchestrate your package execution on SQL Server, you can continue using it to orchestrate them on SSIS-IR in ADF via Azure-enabled dtexec command prompt utility that can be configured on SSMS and invoked by your third-party tool to auto-create and run SSIS activities in ADF pipelines. To preserve the established ecosystem of third-party components, most of our ISV partners have adapted their components using custom setup and third-party licensing interfaces to run on SSIS-IR in ADF. And finally, in terms of pricing, we offer pay per hour for SSIS-IR usage. Its running costs by bringing your own SQL Server license with Azure Hybrid Benefit or AHB option and stopping or restarting it whenever convenient, on demand, or just in time. Now that you run your packages on SSIS-IR in ADF, you can still access data on premises by joining SSIS-IR to a VNet connected to ExpressRoute or a VPN gateway to your on-premises network, or using self-hosted IR installed in your on-premises network as a proxy for SSIS-IR. You can continue to access your existing or new data stores using Windows authentication feature or cloud-first cloud-only features such as Azure Key Vault or AKV and Azure Active Directory or AAD authentication with the managed identity of ADF as a trusted services. To enhance your ETL workflows, you can orchestrate first-class SSIS activities in ADF pipelines and chain or group them with other complementary native ADF activities. Finally, with Azure Monitor integration, you can visually present metrics, interactively query logs, and create near real-time alerts on all SSIS IR and SSIS package execution, while with Azure Data Catalog or ADC integration, you can view data lineage from your ETL workflow. Let's learn how to secure data access from SQL Server Integration Services or SSIS, Platform as a Service or PaaS. As most of you know already, secure data access from SSIS on-premises can be ensured by placing SSIS engine and data stores in the same network behind a corporate firewall. Secure data access from SSIS PaaS, which is essentially SSIS Integration Runtime or SSIS IR in Azure Data Factory or ADF, can be achieved via several features. For example, you can join SSIS IR to a virtual network or VNet where your data stores are also injected into the same VNet, configured with VNet service endpoint, or connected via private links or private endpoints in the same VNet. You can use self-hosted IR as a proxy for SSIS IR, where it can be installed in the same network where your data stores reside behind a corporate firewall. You can store your access credentials in Azure Key Vault or AKV, and if you want to omit credential from your SSIS packages altogether, you can use Azure Active Directory or AAD authentication with the managed identity of ADF as a trusted service. You can also bring your own static public IP addresses for SSIS IR, so you can allow them on your data store firewalls. VNet injection and self-hosted IR as a proxy are two alternative methods for on-premises data access from SSIS IR. With VNet injection, you can join SSIS IR to a VNet connected to your on-premises network via Express Route or VPN gateway, so your on-premises data stores will be assigned private IP addresses that are accessible by SSIS IR in the same VNet. With self-hosted IR as a proxy, you can install it in your on-premises network where your data stores reside. Once enabled, supported data flow tasks in your packages will be broken down into on-premises staging tasks that run on self-hosted IR to move data between on-premises data stores and Azure Blob Storage Container as a staging area, and cloud staging tasks that run on SSIS IR to move data between the staging area and cloud data stores. Both on-premises data access method can be used without redesigning your existing packages, since modifying relevant connection string to use private IP addresses and enabling the connect by proxy property of relevant connection managers can be done at runtime by assigning the appropriate values to your SSIS parameters, connection manager properties, or property overrides. Let's enumerate the pros and cons for VNet injection of SSIS IR to access data on premises. The pros are, for example, it uses SSIS IR, which is a managed infrastructure. It supports all SSIS components, and it moves data from and to on-premises data stores directly without staging. The cons are, for example, it depends on SSIS IR original availability. It requires complex network configuration with many requirements to consider. For example, it requires Network Security Group or NSG on certain ports that allows outbound traffic from SSIS IR inside your VNet to other Azure resources. And it may require some or more exemptions from company-specific network policies. For example, it requires certain network resources to be auto-created inside your VNet, such as a public IP address, load balancer, and NSG that allows inbound traffic from Azure Batch, our underlying infrastructure, into your VNet to manage SSIS IR. With VNet injection of SSIS IR, you can also configure forced tunneling for outbound traffic inspection. You can audit or inspect all outbound traffic from SSIS IR inside your VNet by redirecting it to a network virtual appliance or NVA, Azure Firewall, or on-premises firewall but you must allow the outbound traffic required by SSIS IR using firewall rules and exclude all traffic from and to Azure batch that manages SSIS IR by configuring a user-defined route or UDR. Let's enumerate the pros and cons for self-hosted IR as a proxy to access data on premises. The pros are, for example, it does not depend on SSIS IR regional availability. It is simple to install and configure, as it is enabled by a single connection manager property, which is connected by proxy, and it can reuse your existing Azure Blob Storage link services in ADF to set up the staging area. And it requires no or less exemptions from company-specific network policies. For example, it has no inbound traffic into your on-premises network. The cons are, for example, it uses self-hosted IR, which is an unmanaged infrastructure. It supports only some data flow components for now, and it moves data from and to on-premises data stores indirectly with staging. Let's explore the extensibility features for SQL Server Integration Services or SSIS, Platform as a Service or Paas. SSIS Paas, which is essentially SSIS Integration Runtime or SSIS IR in Azure Data Factory or ADF, comes in two flavors, Standard and Enterprise Edition. SSIS IR Enterprise Edition allows you to use advanced or premium features such as Change Data Capture or CDC components, Oracle, Teradata, and SAP BW connectors, SQL Server Analysis Services or SSAS, and Azure Analysis Services or AAS connectors and transformation, fuzzy grouping and lookup transformation, term extraction and lookup transformation. Some of these enterprise features, such as Oracle, Teradata, and SAP BW connectors, will also require you to install additional components, essentially customizing your SSIS IR via its custom setup interface. The custom setup interface allows you to add your own setup steps during the provisioning or reconfiguration of your SSIS IR. For example, to start additional Windows services, add Windows environment variables, persist Windows authentication credential to access data stores, enforce strong cryptography or more secure network protocol, and install additional custom open source or third-party components, including APIs, drivers, assemblies, connector, extension, etc. You can configure a standard custom setup on SSIS IR by following these steps. First, prepare an entry point script or main.cmd plus associated files and upload them into a blob container in your Azure storage account. Next, provide a long-life shared access signature uniform resource identifier or SAS URI with read and write permission for your container when you provision or reconfigure your SSIS IR. Each node of your SSIS IR will then download the script plus files from your container and execute your custom setup with an elevated privilege. Upon completion, each node will upload the standard output of execution and other logs into main.cmd.log folder in your container. For common or popular custom setups, we now provide express custom setups that require no script nor blob container. Standard and Express custom setups support the installation of free or unlicensed and paid or licensed components. To support the installation of paid or licensed component from our independent software vendor or ISV partners, we face challenges from the dynamic nature of SSIS IR, where its nodes are volatile in the sense that they can be allocated or released at any time. For example, we regularly reimage the nodes to release security patches or new features. Customer can stop and restart their SSIS IR to manage its running costs. Customer can scale up and down through various node sizes, and customer can scale in and out the number of nodes between 1 to 10 or more by a special request. Consequently, collecting machine-specific info such as MAC address or CPU ID, etc., that's traditionally used in on-premises installation to bind a component license to any particular node is not viable anymore. To facilitate license binding and validation on SSIS IR for our ISV partners, we provide new, unique, and persistent Windows environment plus SSIS system variables to identify SSIS IR. These are SSIS IR cluster ID and cluster node count. Here is a typical implementation of third-party extensibility for SSIS IR. The little guy on the left represents our customer who has paid for a third-party component from our ISV partner and received a custom setup script with product key and associated files to install on his SSIS IR. At setup time, when he provisions his SSIS IR, the custom setup script will run on each node to obtain his SSIR cluster ID from Windows environment variable and submit it together with the product key to the ISV's activation server to get an activation key. After receiving the activation key, the custom setup script will locally store it, for example, in a registry, and install the associated files on each node of his SSIS IR. This is the license binding process. At runtime, when he runs packages on his SSIS IR, the third-party component will fetch the locally stored activation key and validate it against his SSIS IR cluster ID from SSIS system variable on each node of his SSIS IR to ensure that it is licensed to run the third-party component. This is the license validation process that could also optionally report his SSIS IR cluster node count from SSIS system variable to the ISV's activation server. Here is a list of our ISV partners who have adopted their existing paid or licensed components to run on SSIS IR in ADF via standard custom setup. Some of them have also deeply integrated their components to run on SSIS IR in ADF via express custom setups. Let's review the recommended process, actions, and tools for SQL Server Integration Services or SSIS migration. The SSIS migration process usually starts with a database administrator or DBA or anyone else who has access to existing SSIS projects or packages. He can use Data Migration Assistant or DMA to perform SSIS package assessment for cloud compatibility in batches for packages stored in SSIS Catalog or SSIS DB hosted by SQL Server, in SQL Server Database or MSDB, in file system, or in SSIS package stores on top of MSDB or file system. He can also use Azure-enabled SQL Server Data Tools or SSDT to perform SSIS package assessment project by project in batches or package by package. SSIS package assessment will generate a report that highlights any potential issues when running those existing packages on SSIS Integration Runtime or SSIS IR in Azure Data Factory or ADF and offers specific recommendations to mitigate them. The DBA can export SSIS package assessment report into a CSV file that can be shared with a business intelligence or BI developer or anyone else who could mitigate those potential issues. The BI developer can also use Azure-enabled SSDT to perform an iterative process editing or redesigning existing packages if necessary to mitigate potential issues, testing package executions in Azure, and reassessing those packages. Editing or redesigning your existing packages is likely to be unnecessary since modifying them can be done at runtime by assigning the appropriate values to your SSIS parameters, connection manager properties, or property overrides. Once the BI developer has mitigated all potential issues, he can redeploy existing SSIS projects or packages or ask the DBA to migrate them in batches from SSIS DB or MSDB hosted by SQL Server or from file system to SSIS DB hosted by Azure SQL Database or SQL DB, to SSIS DB hosted by Azure SQL Managed Instance or SQL MI, to MSDB hosted by SQL MI, to Azure Files or to file system, using Database Migration Service or DMS, Integration Services Deployment Wizard, dtutil command prompt utility, or manual copy. Let's go through the complete SSIS Migration Playbook, which is a 4x5 matrix of recommended actions and tools to assess and migrate existing SSIS packages, as well as to migrate existing SSIS jobs based on the storage types for packages and Azure destinations for SQL migration. For example, if the storage type is SSIS DB and Azure destination is SQL MI with MI Agent as orchestration tool, you can use DMS to migrate existing SSIS packages from SSIS DB hosted by SQL Server to SSIS DB hosted by SQL MI. If the storage type is file system and Azure destination is SQL DB with ADF as orchestration tool, you can use SSIS Job Migration Wizard on SSMS to migrate existing SSIS jobs from SQL Server Agent to ADF. If the storage type is MSDB and Azure destination is SQL MI with MI Agent as orchestration tool, you can use dtutil command prompt utility to redeploy existing SSIS packages from MSDB hosted by SQL Server to MSDB hosted by SQL MI and reconfigure the storage type with SSIS IR package store. And finally, if the storage type is SSIS package store and Azure destination is SQL DB with ADF as orchestration tool, you can use SSIS scheduling feature on SSMS to recreate SSIS jobs in ADF. Let me show you how to provision SQL Server Integration Services Integration Runtime or SSIS IR using Azure Data Factory or ADF portal. On Azure Portal dashboard, select your existing ADF resource style to open its overview page where you can launch ADF portal. On ADF overview page, select the author and monitor link to launch ADF portal where you can provision your SSIS IR. On ADF Portal Home Hub, select the Configure SSIS Integration option to open the Integration Runtime Setup pane, where you can configure the general, deployment, and advanced settings for your SSIS IR. On the General Settings page, you can enter the name of your SSIS IR. You can enter the description of your SSIS IR. The type of your SSIS IR is fixed to Azure SSIS. You can select the location of your SSIS IR, recommended to be the same as the location of your Azure SQL Database Server or Managed Instance that hosts SSIS Catalog or SSIS DB, so cross-regional network latency can be avoided when your SSIS IR writes package execution logs into SSIS DB. You can select the node size of your SSIS IR, scale up and down from 1 to 64 CPU cores and from 3.5 to 432 GB RAM per node to run compute or memory-intensive packages. You can select the cluster size of your SSIS IR, scale in and out between 1 to 10 nodes per cluster to run packages in parallel across multiple nodes. select the SQL edition or license of your SSIS IR, Standard or Enterprise. Select Enterprise Edition or license to use advanced or premium components such as Change Data Capture or CDC components, Oracle, Teradata, and SAP BW connectors, etc. Finally, you can select Azure Hybrid Benefit or AHB option to bring your own SQL license for your SSIS IR. Save money by paying only Azure VM and manage service charges. On the deployment settings page, you can select the option to create SSIS DB hosted by your Azure SQL Database Server or managed instance. Select it if you use project deployment model to deploy your projects or packages into SSIS DB. Unselect it if you use package deployment model to deploy your packages into file system, Azure Files, or SQL Server Database or MSDB hosted by your Azure SQL Managed Instance. But regardless of your deployment model, select it anyway if you want to use your Azure SQL Managed Instance agent to orchestrate or schedule your package execution. You can select the Azure subscription, under which you can then select your Azure SQL Database Server or Managed Instance. You can select the location of your Azure SQL Database Server or Managed Instance. Recommended to be the same as the location of your SSIS IR, which is selected by default to avoid cross-regional network latency as previously mentioned. You can select the endpoint of your Azure SQL Database Server or Managed Instance. These can be used later to connect from familiar on-premises tools, such as SQL Server Data Tools or SSDT and SQL Server Management Studio or SSMS. You can select the option to use Azure Active Directory or AAD authentication with ADF managed identity, so we can create and manage SSIS DB on your behalf. This requires you to add ADF managed identity into an AAD group with access permission to your Azure SQL Database Server or managed instance. Alternatively, you can enter the admin credential for your Azure SQL Database Server or managed instance, so we can create and manage SSIS DB on your behalf. Finally, if you don't use Azure SQL Managed Instance, you can select the service SSIS DB hosted by your Azure SQL Database Server. Scale up and down from basic to general purpose, business critical, and hyperscale tiers for a single database or use elastic pool. You can also select the option to create SSIS IR package store to manage your packages that are deployed into file system, Azure Files, or MSDB hosted by your Azure SQL Managed Instance. You can select the plus new button to add a new SSIS IR package store. You can enter the name of your SSIS IR package store. You can select the name of your existing ADF linked service that contains access information for file system, Azure Files, or Azure SQL Managed Instance, where your packages are deployed, or create a new one with basic authentication. If you don't want to create SSIS DB or SSIS IR package stores, you can still deploy your packages into file system or Azure Files, or embed them in your ADF pipeline payload. On the Advanced Settings page, you can select the concurrency level of your SSIS IR node to run a single package using more than one cores, or run one or more packages using a single core. You can select the option to customize your SSIS IR with additional system configuration or component installations via a standard custom setup script or express custom setups without script. You can enter the Shared Access Signature Uniform Resource Identifier, or SAS URI, of your Azure Storage Blob container, where your custom setup script and associated files are stored, so they can be downloaded and run on each node of your SSIS IR. You can select the plus new button to add a new Express Custom Setup without script on your SSIS IR. You can select the type of Express Custom Setup. For example, to run Windows CMD key command that persists data store access credential, to add a Windows environment variable that can be used in your packages, to install a third-party paid or licensed component that extends your extract, transform, and load or ETL workflow, or to install Azure PowerShell that can be used to manage other Azure resources. To run a CMD key command, you can enter your targeted computer or domain name, your account name or username, and your account key or password. To add an environment variable, you can enter your variable name and value. To install a license component, you can select one of many from our independent software vendor or ISV partners and enter the license key that you have purchased from them. To install Azure PowerShell, you can enter the version number of AZ module you want. You can also select the option to join your SSIS IR to a virtual network or VNet. This is required if you use Azure resources in a VNet or configured with VNet Service Endpoint or Private Endpoint. For example, your Azure SQL Database Server or Managed Instance that hosts SSIS DB, Azure Storage that stores your custom setup script and other files, or Azure Key Vault or AKV that secures your credential and other secrets. This is also required if you want to bring your own static public IP addresses for SSIS IR or need to access data on premises without configuring self-hosted IR. You can select the Azure subscription, under which you can then select a VNet for your SSIS IR to join. The VNet location is fixed to the location of your SSIS IR. The VNet type is fixed to Azure Resource Manager or ARM VNet. You can select the name of your existing VNet or create a new one. You can select the name of subnet under your selected VNet. You can select the options to bring your own static public IP addresses for SSIS IR that can be allowed on data store firewalls, or leave it unselected to assign dynamic public IP addresses to your SSIS IR. You can select two unused standard static public IP addresses with DNS name for your SSIS IR. If you don't have any, you can create new ones or modify existing ones on Azure Portal to meet the selection requirement. Alternatively, you can select the option to configure self-hosted IR as a proxy for your SSIS IR. This is required if you need to access data or resources on premises in a VNet or configure with VNet service endpoint or private endpoint without joining your SSIS IR to a VNet. You can select the name of your existing self-hosted IR. You can select the name of your existing ADF link service that contains access information for Azure Blob Storage or create a new one. This will serve as a staging area when self-hosted or SSIS IR processes data. You can enter the path for staging area in your Azure Blob Storage, or a default container will be used. On the summary page, you can find the general deployment. You can find the general deployment and advanced settings you have configured. You can also find documentation links that you should bookmark. They will guide you to deploy your projects or packages and manage the running cost of your SSIS IR by starting and stopping it whenever convenient, on demand, or just in time. Finally, you can start your SSIS IR. On ADF Portal Manage Hub, you can find your new SSIS IR starting. Excluding any custom setup time, it should be running within 5 minutes, but it might take longer when it joins a VNet. To conclude this session, here are the resources you can use to follow up on this topic. For context, here are my email address and the link to our SSIS team blog. For more info, here are the links to our SSIS and ADF documentations. Thank you for your attention.